welcome everybody. My name is Michał Lisiecki and I work at Altkom and have the pleasure to manage a team of high-class specialists who have been working with Camunda for years. We are delivering Camunda-based solutions for large enterprises from different sectors like financial, automotive, or logistics. So we have a lot of experience in this topic, and due to the appearance of the Camunda 8 version this year, we decided to organize this webinar and share with you some findings and our thoughts about this version and challenges that it brings to us, both from the technical and licensing model point of view. Mariusz Kozłowski, who is with me today, will lead this part. After, I will talk a few minutes about our solutions that are helpful in addressing the challenges coming from Camunda community version, which we are working mostly. And finally, we reserve some slot for a quick Q&A. So Mariusz, the floor is yours.
So thank you, Michael. So welcome everyone. Thank you for joining this Camunda webinar. My name is Mariusz Kozłowski, and I'm IT solution architect and software engineer with proven experience in business process design and implementation. So today I'm presenting a sneak peek into the future of Camunda Platform 8, architectural changes, and of course challenges. Okay, so let's start with the agenda for today's webinar. To begin with, I'd like to say a few things about Camunda Platform components. Then I'd like to take some time to define the differences between version 7 and 8. And after that, I move on the next item and outline an example of migration plan. Finally, I will hand the presentation over to Michał, who will tell you how Altkom can support you with your process solutions. Before I speak about the future, I'd like to bring back the history of Camunda Platform 7. Camunda Platform 7 has a long history, which started as a fork of the activity project in 2013. 18th of March 2013, Camunda decided to fork an open source project activity and create a new BPMN workflow. Since then, Camunda has released many versions with new features and has become the largest open source platform for business processes, enabling the creation of solutions for process digitalization, automation, and orchestration of systems and, of course, people. On 12th of April 2022, Camunda announced groundbreaking news: the release of a brand new, as they call, universal process orchestrator, Camunda Platform 8. Camunda has decided to meet today's business requirements, where performance at scale, high availability, and elasticity are the main focus. They have determined to design, build, and operate an entirely new business process engine. The new engine, ZB, was designed and implemented from the ground up. Camunda explained it is a next generation cloud native workflow engine. And the following pillars are new engine foundation: performance, scalability, and resilience. And this leads directly to my next point, the components of Camunda Platform 8. So the components of Camunda Platform 8 classifies into two groups: user-facing components, the components that the user accesses directly, and of course, core components for processing and managing processes. The user-oriented component group consists of the following applications like modeler, operate, task list, and optimize application. The modeler. So everyone involved in the analytical process of designing solution knows that having ubiquitous language between team members is essential. Complex business logic and requirements are difficult to grasp. So a tool that connects business analytics and software engineers is crucial in today's reality. Camunda Modeler uses standardized notations such as BPMN and DMN languages, so that business and technical stakeholders can collaborate and understand the process. Using graphical process building blocks, you can easily model any business logic and deploy it directly into the process engine. Camunda offers two types of modelers. One open source new desktop modeler available to download, unzip, and start designing your process directly from your desktop. And the second one is a Camunda web modeler distributed as a software as a service solution and requires a subscription. Of course, there's a free tier where you can choose and check how to model your diagram, limited to five definitions. So you've already have your definition deployed to your new process engine and started your new process instance from this definition. So you need a graphical user interface to manage this process instances, to check what's going on. So the second group of application are task list, operate, and optimize. The first is the task list. Application allows process designers to implement business logic alongside user tasks. It's a place where you can orchestrate your business process from a human task perspective. The operate application is an operational tool for managing, monitoring, and troubleshooting process instances running in Camunda Platform 8. Operate replaces the Camunda Platform 7 cockpit application. And the last one is the optimize application. It's an intelligence tool that helps IT teams and business stakeholders perform analysis and monitoring to uncover any process bottlenecks. And the second group of components of Camunda Platform 8 are the core components. So process digitalization and the practical approaches, and of course, and best practices start at the foundational level. In today's reality, any business needs a robust process platform to deliver fast and secure solutions. And the answer from Camunda Platform 7 is ZB. ZB as a workflow engine. So ZB workflow engine automates processes at scale, eliminates the bottleneck created by traditional databases dependencies, and allow for essential linear scaling. So as the system workload increases, you can add a cluster node to process additional transaction with consistently low latency and high throughput. The second component is a decision engine, DMN. From ZB's point of view, Camunda DMN is an external service capable of performing decision evaluation tasks. The new engine uses a ZB Scala-based worker, firstly developed by the community, and now it's an integral part of Camunda Platform 8. The next thing is connectors. So a connector is a reusable building block, uses a custom task element in a BPMN process definition that performs integration with an external system. It consists of two parts, a connector function, and the second part is a connector template. So connector function, it's a simply implementation of a business logic, integration business logic. And connector template is a configuration for graphical user interface that provides forms for configuration in the modeler. And the last box is a deployment, a new deployment strategy, Helm and Kubernetes. So Camunda Platform 8 is available for different types of deployments. We can select from software as a service, so Camunda Platform 8 software as a service, or Camunda Platform 8 self-managed. So software as a service, so Camunda hosts the process engine, no setup or installation is required. So this route requires only an enterprise subscription, which you can purchase from a Camunda representative. And the second deployment model is self-managed. So individual setup and install the Camunda platform on your infrastructure. You can choose between you can choose between an enterprise and open source ZB license. So you can choose enterprise or open source. Yeah. So after this brief introduction to the Camunda Platform 8 components, let us dive deeper into the changes and challenges that come along with the new Camunda Platform 8. And this brings us to the next point, feature comparison. Well, so let's start from Camunda 7. So Camunda 7 is a lightweight open source BPMN platform distributed as a Java file. It offers flexibility in terms of deployment options, namely standalone, remote, or embedded, for example, as a microservices. Production deployment required at least 2 Camunda 7 nodes with shared relational database management system. And the database is a central repository required for storing and sharing process state data. Camunda 7 can be efficiently scaled horizontally and vertically by adding nodes or resources to the cluster. However, the database can be a bottleneck. Each node in the cluster connects to the same database and operates on the shared table set. Process instances state replication is out of the scope of the Camunda engine. It relies on a master-slave database replication setup. So on the other hand, we have a Camunda Platform 8, a new cloud-native process engine. It consists of brokers and gateway components. A gateway component is an access point to a ZB cluster. The ZB broker is the distributed BPMN engine responsible for managing state of active process instances. The reactive engine uses event sourcing, event streaming concepts, and replicated append-only logs. And moreover, data partitioning allows for scaling out. ZB is the same class of systems as Apache Kafka. It stores record streams directly on a local file system and replicate them to the replica nodes. Thus, ZB doesn't depend on an external database. So when it comes to the strategy for deploying process engine, Camunda 7 offers a wide range of options. The options start from application server deployment throughout servlet containers like Apache Tomcat and end with Spring Boot application embedded engine. As for the licensing model, it offers 2 options, an open source Apache license and enterprise. On the other hand, Camunda 8 has the following option to deploy and run the process engine. So to begin, you have a choice between software as a service enterprise model or self-managed fashion, enterprise or community. Camunda strongly recommends using Kubernetes for production. They also officially support a variety of vendors, namely Red Hat OpenShift and Amazon Elastic Kubernetes Service. You also have the option to run Docker images in production using the Docker Compose configuration. And if you prefer, you can also perform your installation manually. It's important to emphasize that Windows and Mac OS systems are now supported for the production use of ZB. Okay, and there are two options for licensing Camunda 8. A commercial license for self-managed and software as a service deployment, or ZB community license. And ZB community license is similar to Apache license with restrictions. The restriction regards managed services that allow its end user to modify process models or deploy ones are not allowed. It does not allow the software as a service solution with ZB as a direct competition to Camunda software as a service solution. So for more information, I encourage you to read the license from Camunda documentation with valuable examples. So let us now move to the user-oriented components. So the cockpit, task list, and admin application provide a user interface for process instances, definitions, incidents, and human task management in Camunda 7. There are significant differences between the enterprise and open source version, especially in the range of functions available to customers, to users. Yeah. And Camunda 8 offers the fully featured application, task list, operate, and optimize for free use for non-productive purpose without a subscription. In both platforms, 7 and 8, the modeling functions are utterly similar. They provide free of charge desktop modeler. It's also worth noting that Camunda 8 engine does not yet support all BPMN elements supported by Camunda 7 engine. The BPMN coverage is available on official documentation. Okay, so let's move on. And Camunda 7 offers a simple API for integration with HTTP services out of the box. It's Camunda Connect. And Camunda Connect provides an HTTP and SOAP connector and allows you to introduce custom connectors, a custom implementation of connector. On the other side, Camunda 8 offers a different solution called connector. As a reminder, it's a reusable building block for integration with an external services represented as an activity task in a BPMN diagram process. So depending on the deployment strategy, software as a service or self-managed, Camunda software as a service provides a runtime environment for the connectors, or you manage the execution environment yourself if you choose self-managed deployment. The redesign of the process engine API represents a fundamental change in how to integrate with the engine. The Camunda 7 process engine provides direct access to all relevant interfaces via a uniform, well-developed REST API, and of course, Java API. On the contrary, stateless Camunda 8 gateway and client services communicate via open source gRPC protocol. So this communication protocol uses HTTP2 and protocol buffers version 3, which is an interface definition and data serialization mechanism. It also supports client generation in various programming languages. So ZB officially support Java and Golang gRPC clients. And the community developers developed client libraries in C#, Ruby, Python, Spring, JavaScript, and others. Yes, and the last row in this feature comparison, variable types. So what about the process variables? So they represent the process instance state. Camunda 7 offers different variables type, primitives like string, boolean, double, integer, etc., and complex type like object, serialized object, XML, and JSON variables. Camunda 8 simplifies and enables only JSON data types. Yes, so let us briefly summarize the core quality attributes of Camunda Platform 8. So starting from horizontal scalability, high availability, and fault tolerance, deliver an enterprise resilience level. ZB Engine distributes data across all brokers in a cluster and stores it directly on a file system. It guarantees data replication and automatic recovery from machine or software failure. A loose coupling and strong cohesion are the principles of microservice communications. ZB's brokers and client services communicate entirely via asynchronous integration patterns. The reactive publish-subscribe interaction model ensures that client and process engines aren't overloaded. A language-agnostic feature enables software engineer to choose gRPC-supported programming language to handle business logic implementation. ISO standard BPMN and DMN languages used to design visual process blueprints, facilitate collaboration and process digitalization. And now, yes, and the next point is the migration from Camunda 7. So let me present a brief contrast between platforms that directly impact solutions while transforming from version 7 to version 8. So the first is the engine deployment strategy is the first challenge. So Camunda 7 supports a standalone, remote, or embedded engine setup. The wide range of choices between container or application server, such as Apache Tomcat or Whitefly, in combination with ZB's remote Kubernetes cluster, requires a fundamental change in operation and deployment process. Then we have to focus on data and API. As I've already mentioned, process variables are an essential part. Camunda 7 platform data repository is a relational database management system, such as PostgreSQL or Oracle. And process variables spread into database tables in columnar fashion. BPMN diagram designs and business logic implementation utilize a primitive and complex data types variables. Moreover, business logic can use Camunda 7 platform REST API or Java API to connect the process engine. On the contrary, Camunda 8 platform generates a stream of records. Each record is stored on a local file system and replicated across ZB brokers. The engine's clients are unable to intercept this stream directly. Despite that, ZB has an additional mechanism that inspects each record and export it to the external warehouse. The default exporter persists historical data records stream by pushing them into the Elasticsearch indexes. The exporter feature allows also the implementation of additional bridges between ZB and the external data warehouse, but it's only available in Camunda Platform 8 self-managed. Exporters are not available in Camunda Platform 8 software as a service. So to interact with the ZB cluster, client use the gRPC protocol. Another challenge to deal with is business logic implementation, a glue code, let's call it a glue code, yeah, as Camunda. So Platform 7 execute code of a business logic directly on the same Camunda's JVM as Java delegate implementations. Currently, Platform 8 delegates the entire business logic to external job workers. So regarding expressions which are handy when automating a process using a BPMN or orchestrating human tasks, Platform 8 uses a friendly enough expression language, unlike Platform 7 utilizes a Java unified expression language. The next things are plugins. So what about plugins? Platform 7 provides plugins such as process engines, task lists, cockpit, and admin application extensions. The process engine plugin mechanism enables users to add and adjust engine features. Application plugins introduce the ability to add functionality to an existing application without source code modifications. On the other hand, Platform 8 doesn't provide an equivalent feature. The engine extensions are potential candidates to be turned into a new exporter implementation. However, it always requires re-implementation. Regarding application plugins, there is no way to migrate them to the new task list or operate applications since they are incompatible. So, following the earlier differences, let us look at sample migration plan. The current slide outlines 3 steps for, let's say, successful transition of the solution from version 7 to version 8. So the first step is a preparation. Preparation phase requires an audit of the existing solution. An audit covers the current deployment architecture, identify all integration points, identify business logic implementations like Java delegates, task lists, or scripts, and analyze process definitions and decision diagrams. Upon completion of this phase, the conversation plan is ready for execution. And I recommend using an evolution, not a revolution strategy. In practice, this means that you will follow a shadowing strategy for a while, with one part of your business running on version 7 and the other on version 8. But it always depends on your requirements and business approaches, of course. The second step is development artifacts migration phase. So once you have a completed plan, the next phase is implementation. To do this, you need to create a new deployment environment for Platform 8. Then you need to adjust the internal development, CI and CD pipelines. And after then, that you can start refactoring and implementing your code by adapting or introducing clients to the new ZB API. And the last step is the engine data. So the last part of the migration focuses on process definitions and data. It consists of the following steps. The first part regards applying data migration plan from phases 1 and 2. In particular, this requires a change in the BPMN and DMN definitions. and Platform 8 delegates all business logic outside the workflow engine to external services. Then ZB does not support case management model and notation. So if you have any case management model and notation definitions, you need to convert them to BPMN definitions. And the last, Platform 7 stores runtime and historical data in a relational database management system, while Platform 8 generates a data record stream exported to external data warehouse. So the structure of those data differs significantly. Camunda does not provide a data exporter tool that automatically retrieves data from relational database management system, transform it, and store it in the Elasticsearch index as a default warehouse repository, of course. This operation requires manual effort preceded by throughout analysis of the client's data. The same refers the historical data. Do we have any tools which can help us to deal with this case? So the Camunda community provides a migration toolset to help migrate process solution from Camunda 7 to Platform 8. Migration guide document describes this toolset and provides examples of usage. And the migration toolset contains a desktop modeler plugin and an adapter library. A desktop model plugin to convert definition models, BPMN and DMN, from Platform 7 to Platform 8. The plugin performs an automatic conversion of BPMN definition. The migration process transforms all activities and elements feasible to migrate into the corresponding Platform 8 model. Whenever they are unsupported in Platform 8, it displays a warning for the respective item in the model. So in such cases, definition requires manual adjustment. And an adapter library, it's to reuse Java delegates or expression from Camunda Platform 7 and Platform 8. So the adapter library is a Java-based project designed for Spring Boot implementations. It allows you to reuse existing Java delegates expression or external task from your current Camunda 7 process solution within the Camunda Platform 8 external service. Nevertheless, the adapter doesn't cover all possible implementation strategies and may not be suitable for all cases. However, it can be a good start without investment in the implementation. So now let us review the differences between process solutions. So from Camunda's best practice, we know that recommended Camunda 7 stack for Java language looks like the following, the left side. So process solution built as a Spring Boot application, Camunda engine embedded in Spring Boot application or usage of Camunda run distribution for simple solution, business logic implemented as Java delegate Spring Beans. So let us move to Camunda 8 process solution stack. It looks similar despite the engine client implementation. Java as the foundation, Spring Boot application with ZB starter client, providing access to ZBG RPC engine, and a glue code, the business logic implementation, as the Spring Beans implementation is the default stack. Therefore, this brief comparison presents that technology stack is similar for both process solutions. The difference arises from engine implementation, client API, and of course, a conceptual assumptions. The process solution is one or more applications, Java, Python, Ruby, Go, etc., consisting of DPMN, DMN blueprints, and your business logic implementation. The main difference is that the workflow engine is a remote ZB cluster deployment. So what about the deployments? As I have already pointed out, the representative example of workflow engine deployment differ in the location of the engine. Camunda 7 embedded workflow engine, task list, and cockpit application versus remote ZB cluster with at least 3 instances for resilience and independent task list, operate, and optimize applications. Only, of course, with enterprise subscription for production. Or your custom implementation for production for task list, operate, and optimize application. Then a relational database versus record stream events and data repository of your choice. Default is an Elasticsearch. Default implementation is Elasticsearch exporter. So, and the third one is application server or servlet container deployment versus a Kubernetes or Red Hat OpenShift on premises or in the cloud deployment. Now, this slide supports shows supported client environment, and it's and presents appealing dependency. ZB engine is well liked by the open source community. On the left side are official clients developed by Camunda. So we have Java, Go, and command line interface clients. And on the right side are community drive clients for the following languages and framework like C#, JavaScript, Node.js, Micronaut, Python, Ruby, Rust, Spring, and Quarkus. The list is still growing, so the community is still working on a new clients to new ZB gRPC engine. And finally, it's possible to add your client to that list. And now let us look at this table that presents the technical requirements for the Camunda Platform 8 components. The table contains all elements of Platform 8, ZB license, and of course enterprise license. So ZB broker and gateway require Java 17 plus and Elasticsearch only if workflow uses the default Elastic exporter. Next, there are 3 user-oriented applications that anyone without an enterprise subscription can use for non-productive deployments. Task list, operate, and optimize demand Java 11 plus and Elasticsearch. And the identity component requires Java 11 and open source Keycloak, responsible for identity and access management solution in Camunda Platform 8. Okay, so now I'd like to focus on how open is Camunda Platform 8. I'd like you to look at this diagram. It depicts the various components that compose Camunda Platform 8. The different colors of elements denote various license types. Thus, this picture gives you a breakdown of the Camunda Platform 8 license model. Diagram clearly shows that Camunda desktop modeler, ZB client libraries, Helm charts files, and Keycloak belong to green color that represent an open source license. The orange group represents the source available license, ZB community license. The license is open source and liberal with one restriction. Users are not allowed to use the component for providing a commercial workflow service in the cloud. I encourage you to verify the official license document of course, with valuable examples. ZB community license regards ZB broker, ZB gateway, and Elasticsearch exporter. Task list, operate, optimize, and identity applications belong to the blue category. Blue means that software doesn't require an enterprise license for non-production use. Consequently, if you want to deploy this component to a production environment, you must purchase a license via enterprise subscription from Camunda. And the red group represents items only available within Camunda 8 software as a service model. That means you cannot use them on self-managed deployment, even if you have an enterprise subscription. Camunda states that red components are subject to turning into blue over time, and the newest 8.1 release offers web modeler as a self-managed as a beta release. And now the question is how to run open source Camunda 8 self-managed on premises or in the cloud. So the current diagram shows an example of architecture. It uses open source element and a ZB community license component with a custom implementation of the operate, task list, and identity applications. This means that open source self-managed deployment required custom implementation of the task management and the operate application with a custom persistent layer and API. The same regards process-based analytic application, which is optimized. That's optimized, yeah. And the final solution depends, of course, on your requirements. So, yes, for me, I think I finished. So now I will hand the presentation over to Michael.
So thank you, Mariusz.
Thank you.
I see that we have some questions on Q&A, so I will try to quickly wrap about the products we already offer for Camunda community version and why we offer them, and we'll switch to Q&A. So during working with Camunda community, we know that there are some limitations when we put the Camunda community on production and when we serve huge traffic and want to have detailed knowledge about processes. So in order to work with community flexibly and in a friendly environment, we developed a product called Control Center, which addresses all the limitations and allows to use community version on production with giving you all the information you need to operate the processes. And the second product, which is Digital Product Center, it's more than Control Center. It includes Control Center. However, it's more like a platform that speeds up the process of development of processes. So it works based on Camunda community, and all the components from Camunda community version are available. However, we add some modules that will give you such possibilities like creating online forms that could be exposed to internet in the WYSIWYG mode. Or there is a product catalog which allow you to manage the products that are served by processes. There is also the API gateway available. So it's more that extension of all the features that I required to speed up the development. Both of these products are already implemented in customers' environment and still being developed. That's all. Just quick recall about our products. If you want to learn more, please contact us, and we'll be happy to share them more details about it. Mariusz, the floor I can give you if you're ready for Q&A.
Okay, let me check what kind of question do we have. Okay. How does system recovery in Camunda 8 work when your cluster completely shuts down? as example because of a fire in a data center. When you're designing your solution, you always need to think about redundancy. So having an example on AWS, in such a cases, you can deploy your ZB cluster in multiple availability zone, and in case of having a fire in a data center in one availability zone, always you have available your brokers, which are replicated and connected across multiple availability zones. So this is the case of your deployment and how you manage your deployment in a disaster recovery plan. Yeah. So, you know, if you have one data center and you put all your components in this one data center, there is no way to achieve system recovery from such a case. You always need to think of deploying it redundantly. So the Kubernetes servers, the Kubernetes cluster should be replicated across multiple data centers. Okay, no embedded engine. Can we get some example on ACID transaction between application code and workflow engine? So as Camunda stated, you shouldn't rely on transaction managers, for example, JTA transaction managers like you can use on Camunda 7 deployment. You should treat Camunda workflow engine as an orchestrator of independent services, and each service should have its own transactions. And whenever whenever the problem arises, it should roll back the transactions, and the Camunda can orchestrate for transaction rollback and recover from such a situation. And you can model directly on your BPMN diagram such a situation. For example, by throwing an error to your BPMN diagram and model it on your definition directly. Okay. The next question. What about a lack of cockpit in open source version? Yes, there is no cockpit cockpit application for production. You can easily use a cockpit application, which in Camunda Platform 8 is an operate application. But for non-production releases, non-production deployment. So there are two options. You can buy enterprise license, or you can create by your own a solution which gives you features like cockpit or operate in Camunda Platform 8. Okay. Well, a lot of questions. For starting the new project, is it advisable to start with Camunda Platform 7 version? As 7 version is more flexible, you can be used as embedded engine. Is it not more useful to use 7 instead of 8? Okay, so Camunda officially recommends in such a case to start using version 8. But if your business requirements or any other conditions are that you should use version 7, so you can also use version 7, but writing a clean Java code delegation, the clean Java code delegate For example, instead of using a service delegate with Java delegate implementation, you can use external service delegate, which resembles the same activity as the ZB worker. So external service task delegates work to external worker, for example, external microservices. Yeah, but the answer is it depends on your business requirement. But from the official recommendation from Camunda, they recommend to start using Platform 8. Okay, if I'm developing Camunda 8 self-managed, does the ZB cluster require local persistent storage? My nodes cannot provide long-term persistent storage of the ZB broker. Is there an opportunity to store state externally? Yeah, I think that I can't answer for this question now, but I will be happy to answer for your question maybe after this webinar, but I need to figure out how to deal with such a case. Okay. The next question for serialization, deserialization, and it's how does it work in Camunda 8 platform since there is no spin library? Okay, there is no serialization and deserialization. The data are written in a JSON. The variables are JSON, so it's a simple. You don't have to serialize and deserialize, and of course, it's a matter of your exporter. Because exporter intercepts each record stream, and default exporter is an Elasticsearch exporter. So the transformation of this record are transferred into the canonical data, which is represented as a data in an Elasticsearch index. So if you would like to write your custom exporter to export the record stream to your custom data warehouse, it's a matter of your implementation, the serialization and the serialization process. Okay, are Control Center and Digital Product Center available for, yeah, Michael?
Maybe I will take this one.
Okay.
So as our customers work with Camunda 7 for years, these products are developed for Camunda 7 edition. However, currently we are working on Camunda, adapting to Camunda 8, and we are preparing for migrations plan because our customers probably sooner or later will start migrating to Camunda 7 from the supporting issue of Camunda 7. I think it's 5 years. Mariusz?
Yes, 2027.
Yeah, so of course we know how to do it, how to adapt this control center, and if you see the need to have this control center or DPC deployed based on Camunda 8, please contact us and we'll be happy to start a project with you.
Okay, thank you, Michael. And are the WebJS-based BPMN viewer editor tools at BPMN.io comparable to desktop modeler? Yes, the BPMN.io provides several libraries and tools which you can use to build your own solution, your own graphical user interface. And these BPMN.io libraries you can use to build the web modeler. As I can say, we use BPMN.io libraries in our solution in Control Center to provide a web modeler. Okay. And I think
there is one more simple question. However, there's a question: what is the advantages of ZB versus Apache Kafka? So
totally two different system and application. One is a workflow engine application, and two is a Apache Kafka is for distributing messages asynchronously to the client. So I told that ZB maybe compares to is a class of the same as Apache Kafka because it uses the same concept of propagating records and storing them on file system. Yep.
There is one more. So Camunda Platform 8 doesn't cover some features that Camunda Platform 7 has. In example, process migration. How to deal with such a case? Of course, everybody will meet this. One of our services is also professional services. We have experienced teams to deal with such cases. So this is one solution from the technical point of view. Mariusz, could you underline something?
Yeah, this is a good question. So the Camunda team has decided to release Camunda Platform 8, which is incremental improvement of Camunda Cloud, tested by a lot of Camunda users. So Camunda's development team believes in the release early and often strategy. So, however, they catch up on missing features. So for example, the last release 8.1 introduces a process modification to ZB's API. And as far as I know, the process migration API is a work in progress. So, we need to wait for coverage of all features we have in Camunda Platform 7.
Okay. So I think the time's up. So thank you very much for participating in the webinar. I know that the recording will be sent to you if you give your email. So happy to contact us if you are interested in supporting you in the projects based on Camunda 7, 8, or our products. You have all the details in the presentation.